Physicist Richard Feynman once said, "There is a fact, or if you wish, a law, governing all natural phenomena that are known to date. It is the conservation of energy. There is no known exception to this law. But what if there is? Imagine discovering that the most sacred rule in physics, the one that says energy can't be created or destroyed, might not hold true for the biggest thing of all, the universe itself. If that's true, it doesn't just rewrite the textbooks. It changes how we think about reality itself. Because if the universe can make energy out of nothing, what else might it be hiding? The rule we thought couldn't be broken? For centuries, the law of conservation of energy has been a scientific cornerstone. It's simple. In an isolated system, energy never appears out of nowhere and never vanishes into nothing. It just changes form, heat to motion, motion to light, light to chemical energy, and so on. And if there's any system that should be truly isolated, it's the universe. After all, it's everything. There's nothing outside it to dump energy in or suck energy out. So naturally you'd expect the law to hold perfectly, right? But here's the question no one expected. What if the universe is not playing by its own rules? At the quantum scale, the law stands firm. Let's start small. Really small. In the bizarre quantum world, where particles flicker in and out of existence in reality is written in probabilities, you'd expect chaos. And yet here, the law of energy conservation is rock solid. The Schrödinger equation, the beating heart of quantum mechanics, states total energy equals kinetic energy plus potential energy, and that total stays constant. No tricks, no loopholes. So at the smallest scales, the universe plays fair. But what happens when we zoom out? Not just to galaxies, but to the structure of the universe itself. At the cosmic scale, things get strange. Enter Einstein's general relativity, a theory that bends not just space, but the rules we thought we knew. Einstein's equations don't say energy stays the same. They say the combination of energy and momentum remains constant. That's a loophole. It means energy can change, as long as momentum changes in just the right way to balance it. And in a universe that's expanding at an accelerating pace, that's exactly what might be happening. So now the question becomes, is the universe quietly creating and destroying energy right under our noses? How the universe creates energy. Here's our first clue. Empty space has energy. And since space itself is expanding, there's more and more of it over time. The density of this vacuum energy stays the same, but the total, it keeps climbing. Think of it like this. Every slice of a cosmic pizza has the same toppings. But if the pizza keeps growing, you keep getting more toppings overall. Our second clue comes from the redshift of light. As light travels through expanding space, its wavelength stretches, shifting toward red. A longer wavelength means less energy. From our perspective, that energy is simply gone. And no, it's not transforming into dark energy. Physicists have checked. So where does it go? That's the mystery. The mystery of the cosmic horizon. And here's where things get even more uncertain. We don't know the true size of the universe. The observable universe, the part we can see, is about 94 billion light-years across. Beyond that is the cosmic event horizon, a hard limit on what light can ever reach us. What's past that, we have no idea. If the universe is infinite, energy conservation almost certainly fails. If it's finite, but far bigger than we can see, we're still constantly losing the energy from galaxies slipping beyond our cosmic edge. And it forces us to ask, can we even define the system we were talking about when the boundaries keep moving? The case for a cosmic balancing act. Not everyone is ready to throw the law out. Some physicists argue we're missing one big piece. Gravity's energy. Here's the idea. As galaxies move apart, their gravitational potential energy, which is negative, increases. This negative energy could perfectly cancel out the positive energy from expanding space. If that's true, the universe could still be balanced, adding up to zero from the very beginning, a perfect cosmic ledger. But if it's not true, then we're re-looking at a universe that makes up its own energy as it goes. So, does the universe obey the law of energy conservation? At human scales? Yes. At quantum scales? Yes. But for the universe as a whole, the answer might be no. And if that's the case, it doesn't just change physics, it changes our place in it. Maybe the universe isn't a closed system at all. Maybe it's more like an artist with an endless canvas, painting reality in ways we can't yet understand. After all, if the universe can bend one of the most sacred rules in science, what else might it be capable of? Thank you for watching. Please don't forget to like and subscribe. See you in the next video.